Nuclear decay is the process of the nucleus of an atom undergoing a nuclear reaction. In that process of the nuclear reaction, the nucleus changes and particles are released in the form of radiation. So we say that radiation is emitted, that means it's released from the nucleus. The types of nuclei, the types of atoms that undergo nuclear decay are radioisotopes. So radio relates to radiation, and of course an isotope is an atom of an element that has a different number of neutrons. And radioisotopes tend to be the isotopes that have a larger number of neutrons, so that they are heavy and they're unstable. So the process of nuclear decay is a process of emitting or ejecting particles from the nucleus and ejecting energy and radiation from the nucleus to take the nucleus of the atom into a more stable form. So there's a couple of different types of nuclear decay, and we're going to focus on two of them. The first one is alpha decay. So that's the Greek letter alpha. So this is alpha decay. In alpha decay, what's released is 2 protons and 2 neutrons. So that means the particle that gets released actually has a mass of 4 and an atomic number of 2. Now, a particle that's got a mass of 4 and an atomic number of 2 is in fact a helium. Now, we actually say it's a helium nucleus because that's where the protons and the neutrons are, and not, it doesn't involve electrons. So an alpha particle is a helium nucleus, and that's how we express an alpha particle. I'm going to show you an example and write it as a nuclear reaction. And what tends to happen, alpha decay tends to happen when we have larger, heavier elements. For example, uranium. Uranium has an atomic number of 92, and it's got a mass, or this particular isotope of uranium has a mass of 238. So with a nuclear reaction, we write the isotope, the radioisotope on the left-hand side, and then we do an arrow indicating the nuclear reactions occurring, and then we write the alpha particle, and so remember we say that's a helium nucleus. So what that essentially means is that 2 protons and 2 neutrons have been ejected from the nucleus of this uranium atom. So the next thing we need to say is, well, what has the uranium turned into after it's ejected these 2 protons and 2 neutrons? So the way we can predict that is by saying, so for the mass, 238 minus 4, so that must be 234. 92 for our atomic number minus 2, so that means that the atomic number now is 90. So let's grab the periodic table and see what element that must be if it's 90. So here's uranium, and it's lost 2 protons. So we're now at thorium, TH for thorium. And so that's actually called the daughter product, or the decay product. So it started as uranium, an alpha particle was released or ejected from the nucleus, and what's left is thorium. So that's alpha decay. So that's alpha radiation. I want to also show you beta decay as well. So that's the sign for beta. It's again the Greek letter beta. Now, a beta particle is actually a high energy electron. Now that high energy electron is formed when a neutron in the nucleus is changed into a proton. And so obviously a neutron is neutral, but a proton is positive. So what gets released is the electron, one electron. So a neutron changes into a proton. So what effect does that have on the mass and the atomic number? Okay, so let's see, we've lost a neutron, but we've gained a proton. So the mass is not changed. There's no change to the mass. But we've gained a proton. So the atomic number increases by 1. So let's do an example then. Carbon 14 undergoes beta decay. Now, when we express a beta particle, we do this. Now, so E for electron, -1, and we'll do a 0 up here because there's no change in mass, but -1. So what that actually means is we're adding 1 to our number of protons. So what effect is that going to have? 0 change to the mass, so it's still going to be 14, but the atomic number is actually increased by 1, so 6 to 7. So it's actually changed to a different type of atom, different element. And let's have a look. So carbon is here, and it's increased by 1. So it's going from carbon to nitrogen. So in the process of beta decay, this carbon atom has a neutron has changed into a proton, a high energy electron has been released, and the atom is no longer carbon, it's now turned into nitrogen. Okay, so there's a lot there, isn't there? Take home message, alpha decay, we have an increase in the mass and by 4, and an increase to the atomic number by 2. With a beta decay, the mass number is not changed and the atomic number is increased by 1. There's one more type of nuclear decay that we need to talk about, and that's called gamma decay. Now the difference with gamma is that no particles are actually ejected from the nucleus. It's just that the particles within the nucleus are rearranged and energy is released. And the energy is gamma radiation. So the symbol for gamma is that symbol. That means gamma in Greek. And a gamma ray is electromagnetic radiation, very, very high energy.